about dynamical downscaling techniques. And we hope that we will manage to do everything without any obstacles, the practical part, because this morning I tried to do something and it didn't work. And hopefully it will work during our sessions. So without any further ado, please, and the floor is yours.
Thank you, Biljana. So yes, I'm Sophie Daloz. I'm a climate scientist at Cicero. And today I will talk about dynamical downscaling, or another way to say it, regional climate models. And I will try to share my screen now so you can see the slides. Just 1 second. Okay, can you see it?
Yes.
Yes.
Okay, I just need to find a way to. Okay, is it in? Do you see the?
Yes.
Like,
Fine, yes.
Okay. Okay, yeah, and I guess first thing is that if you have questions along the way, please ask me. Do not hesitate to stop me or put it in the chat if you want. But yeah, no problem in stopping and asking for questions along the way. So yeah, the lecture of today is about dynamical downscaling, and we have a full day about that with some practical tasks. But before talking about the lecture, I can show you a little bit the organization for today. I think you might have seen it in the directory where we have all the information for day 2, but just a reminder. So from now to 9:45, I will talk about really theoretical dynamical downscaling and a little bit about how the different tasks will work today. And then we'll have a 15-minute break until 10 o'clock. And then we'll start with the practical task 1. And I think from 10 to 12, for me, it can be a discussion. It's both doing the practical task, but we can also talk about the different question I have related to this task, and also maybe related to your work, because if that connects well with your work, we can also think about it. So again, do not hesitate to ask any question along the way. And then we'll have a break for lunch from 12 to 1:30, and then the afternoon will be dedicated to 2 practical tasks and discussion. And again, maybe trying to link it to your work. And the plan for the lecture, so this 45 now block of lecture, I will start by talking about the background. Why do we need dynamical downscaling? Where does it come from? The advantages of this technique, which is related also to the first task we'll do later, the limitation of this technique, and some of the application. And again, if you have questions, stop me. So before going in the background and what is dynamical downscaling, I wanted to give you a little bit of context, because I imagine you have heard about the release of the last IPCC report very recently, 1 month ago. And I just want to show you, it's a release of the first report. As you know, 2 more reports will come very soon. But in this first report, where they talk about the physical scientific basis of the climate system and climate change, they say they give 2 key messages that I think are really related to what we are talking about today. So they say that it's indisputable that human activities are causing climate change, making extreme climate events, including heat wave, heavy rainfall, and drought more frequent and severe. So from the beginning of the report, there is a strong emphasis on extreme events, and I think that's the emphasis of EXtremeClimTwin. So you can see, like, even in the IPCC report, they talk more and more about extreme events. And the other part, other key message of this report that is related to what we are talking about today, is that they say climate change is already affecting every region on Earth in multiple ways. The changes we experience will increase with further warming. So I think you can see that in these 2 slides, they are already talking a lot about extreme event and regional impacts. So, for looking at these extreme events and these local impacts, you need different techniques. And one of them is the one you have seen maybe yesterday with Rob, the statistical downscaling. But another one is the one we are seeing today is dynamical downscaling or using regional climate model. But you can see that in the IPCC report, this idea of looking at climate change regionally is very important from the start. And I guess, of course, it's important because with climate change, we see that there is this human influence that is the main driver of hot extremes, ocean warmings, the changes we see in frozen areas, and yeah, and many more. But the important part is that in this new IPCC report, they really put a strong emphasis on regional aspect of climate change. So now they have these regional fact sheets that can be interesting maybe for your work, where they really talk about what could be happening in the future for different regions in the world. You have Europe, I mean, of course, America, Africa, and you also have different type of topography. So it can be for also urban areas, it can be for mountainous areas. So yeah, take a look if you working on a specific region and you need to learn about the background about climate change in your region, that can be a good start for your research potentially. So now, yeah, going in the dynamical downscaling part, which is the topic, more the topic of the lecture for today. So a little bit of background. So as you know, we have different tools for looking at the Earth's climate, and one of them are climate models in general. And the climate models are here to help us understand how the climate system works. So you want to understand how maybe clouds are influencing the climate, how volcanic activities, or the interaction between land and the atmosphere, of the ocean and the atmosphere. But of course, one important aspect of those models, of the climate models, is that you want to estimate the likely range of possibilities for the future. So we want to know what are the potential climate, what are the potential futures for us. And that's how, yeah, you use those climate models, and they represent the major components of the climate system, as we see here on the right side. And the first type of climate model that was created or produced was global climate models, as you can see here in the red square. And that was looking at the whole globe. And yeah, and you had divided in those grid cells where different equations were resolved. And they are still very useful tool. We use them a lot, for example, for the IPCC, of course. But now, as you have seen with this IPCC, we really want to look more at the regional climate. And what's important to understand when you want to simulate the regional climate is that the regional climate is determined or depends on the interactions of processes. So you have climate processes at different scales, and you need to represent that correctly. So you have processes at the large scale, the planetary scale, and you have also processes at the regional or local scale. And that needs to be taken into account in your model. So an example of large-scale processes or large-scale natural forces is a volcanic eruption, solar activity, or human activity. That's, of course, happening on the large scale. And the planetary or large-scale forcing and circulation, so you can say that they determine the statistics of weather events, then characterize the climate of a region. But of course, when you're looking at the specific regions, let's see here in the center about Europe, you know that Europe has very local specificities. So for example, if you look at here, you have the mountains, in the center you have the Alps, you have the Pyrenees, but you also have different mountains in Scandinavia. For us, all Norway is this very complex topography of mountains. And you also have very complex land use. So you have agriculture, you have urban areas, you have really different type of land use. And to correctly represent the climate at the local scale, you want to be able to have a correct representation of these different forcings. And that's also very important because these regional and local forcings and circulation modulate the regional climate change signal and possibly fitting back to the large scale circulation. So you really need to be able to represent both the large scale and the local scale. And I don't think I can see the chat. So if you have questions, just unmute and say something because I only see your faces. And of course, the issue that has come recently is that we are more and more interested about climate change at the regional scale, and with these very complex details at the regional scale, climate scientists or modeling people have realized that it's quite complicated sometimes to simulate those specific like extreme events, some type of extreme events or some type of climate processes with a global climate model, because this regional climate model can be too coarse. So for example, if you look at on the right side, you have the grids of the different climate models at the beginning. And for example, at the beginning, you had a grid space of 500 kilometers, and then it went to 250, 180. I mean, it's of course the global climate models are increasing resolution, but if you are thinking about a mountain where the topography is changing very quickly, or if you have a city, or if you have agriculture like fields, of course, it's very complicated to simulate that correctly with a grid cell that is huge at 100 kilometers length. So you need to have another technique, and that's where regional climate modeling or statistical downscaling yesterday is coming. So another way, I'm just giving you showing you another way of looking at that. If you look at this map here, you can see that, so in red, you have all these little squares from the regional climate models, and in blue, you have the grid of a global climate model. And you can see that when you go to the regional climate model, you can really start to represent with very much more fine detail what is actually in your country. Or imagine if it was full of mountains here, you would have a much better representation of the mountains. So as I said before, of course, dynamical downscaling or regional climate models, it's a tool for looking at the regional climate, but or getting regional information, but we have different tools. You have talked about it yesterday with the statistical downscaling. And just for your, if you don't know about it, there are also possibilities of stretching the grids of global climate model. So you can increase the resolution of a global climate model just on one part of the globe, and it's another technique, and it's also good, especially if you're looking at, for example, tropical cyclones. It's a technique that we have used because you don't have to go out of a domain. It's continuous in some way, so it can be an interesting technique in some cases. But today we are focusing on this part on the left, the dynamical downscaling. So a little bit about the methodology behind regional climate models. So basically a regional climate model, we say that it's nested within a global climate model. So you can see here on this image on the right, basically you have the regional, we could imagine that the regional climate model is here in the middle of the global climate model, because the inputs of the regional climate model come from the global climate model. And we call it initial condition or lateral boundary condition. You can also use other type of data, but we can talk about it later if you want. So another way to talk about regional climate model is that global climate model simulates the large scale, and the regional climate model is really trying to refine the information for getting better regional information. Do you have any questions? Is there something that is not clear? Okay. So advantages of this technique. So compared to other techniques, I think one of the main advantage of this technique is that it's based on the physics. It's based on equations. So it's just not a linear interpolation between the information from the global climate model to the local scale. You're really deriving equations at a different for the different grid cells, and you're really doing a physical representation of the climate again. So that's one of the major advantage of this technique. And what is also good with this technique is that it's quite flexible. So you can look at a variety of applications. So depending on this initial and lateral boundary conditions, You can look at the paleoclimate, you can look at climate change. You really have a lot of application. You can look at also now the historical climate and look at processes. You can really do a lot of things with that kind of tool. I just want to give you a little example of the advantages of this technique. For example, if you look at here, the differences in relative change in precipitation over Peru, Western Peru, in a global climate model. So here you can see the changes, positive in blue and negative in red for the global climate model. And the same results, so the same changes for the future in a regional climate model at 50-kilometer resolution. And you can see already how the finer details are appearing over Peru. And you can see even how the changes are different, because I guess you're getting more and more information of the regional scale. And if you go at an even higher resolution, at 10 kilometers, you can even see more and more fine detail appearing. And the reason for that is that here on the right, you can see the topography, so the mountains in Peru. So of course, when you are increasing the spatial resolution and using regional climate downscaling, you're getting a much better representation of the mountains here. And these mountains have, are obviously an important impact on the representation of the climate. So of course, global climate models are very useful and they are used in many applications, but I'm just saying in some applications, for example, when you have a very complex topography with mountains, it can be very useful to use this technique of regional climate modeling or dynamical downscaling. So the limitations, because there are limitations, of course, it's not a perfect technique, unfortunately. And the limitation here is that, as I told you, the nesting, so you put the regional climate model in some way in the global climate model. It means basically that you get information from the global climate model into the regional climate model. However, you don't have this feedback, like the regional climate model is not giving back information to the global climate model, because you could imagine that you could have this response, this exchange of information between the two models. But I guess that would be very computationally expensive, and that's something that's unfortunately in the model. So you only have the large scale information coming into the local scale in the regional climate model. So yeah, it's not intended to correct systematic errors in the large scale forcing fields, basically. And that's why some people prefer using this stretch grid, because you have this interaction between the local scale and the large scale. Potential technical issues you can have. Yeah, it's quite interesting to set up your model at the beginning with a regional climate model. You need to think about quite a lot of things about your boundary conditions, about the physics. There are quite a lot of things that can be a bit tricky when you use regional climate models at the beginning. And for example, you should not put the boundary of your domain over mountains. You shouldn't put them over Greenland. So there are things that you need to consider. It's just not setting a model somewhere. You really need to have a little bit of knowledge on how these models should be set up, and also the physics that you can use. And that's also very computationally demanding. So compared to the technique you have seen yesterday, statistical downscaling, which is very fast and has very low computational need, regional climate modeling has very high computational needs. And finally, for the applications, I mean, we'll talk about the application more today, but it's just for opening a little bit with what will happen along the day. So the first application, of course, is, as I said, because these models are have very different physics. You can set up different physics. You can put different initial conditions. I mean, there are a lot of stuff you can change. With this model, we do a lot of validation, a lot of testing, also adding other models together. You can do model coupling. So you can put an atmospheric model with a land model, or more sophisticated ocean model. There are a lot of stuff you can do in the development and validation of the model. And that's one of the applications for regional climate modeling. And you also, another application, of course, is to look at process studies. So for example, these days, I think we talk more and more about land-climate interactions. So we are wondering, for example, if we remove the forest or if we add more forests, what will happen for the climate? And that's typically something that people do with regional climate models, where they change the vegetation, for example, and try to see what will the impact for the climate. So for example, will you be storing more carbon? Will you be having more extreme events, less extreme events? Is it better for heat waves? So you can do all these tests in regional climate models. And of course, you can also look at different processes like tropical cyclones. You can also look at the interaction between ocean and sea and the atmosphere. It's a very a large range of applications. And of course, for, I guess, our interest today, one thing you can do with the regional climate models is looking at different scenarios for the future. So here you can see the different SSPs. Hopefully you've heard about it, but it's different scenarios you can have for the future. So you have SSP5, the rapid growth, SSP1, sustainability road, but that's basically different ways you can see your future. And you can look at how climate could be for these different scenarios over different regions of the world. And you can look as I said, different processes or different region or different topography. So you can look at land use, at cities, at mountain glaciers and more for these different scenarios. And of course, you can look as our interest today, you can include extreme events. So you can look at, let's say, for example, one of my PhD students now, she's looking at how heat wave, what is the impact of heat wave in cities for different scenarios. And she wants to look at it as a very fine scale to understand really better how it's impacting different parts of the cities. So that's something you can test with regional climate model. Another project we have at Cicero related to that, and I think it could be quite interesting for you also. It's about air pollution and heat wave. And of course, you have this interaction between heat wave and air pollutions and how it's affecting the health of people and the health of the most vulnerable people, maybe younger and older adults. And that's something we are trying to see. And one tool we use for that, there are different tools that we have to use, but one of them is regional climate modeling over Europe or over different cities. So there is really a large range of application for this tool. And I'm happy to discuss it if maybe that's useful for your research. So I'm done with this introduction and I will talk about the task, but do you have any questions? Okay. So for the task, normally, if I didn't do anything wrong, you should have a folder for in the directory for day 2. You should find in the folder a Word document where you have all the information for the different tasks, like we did a few weeks ago. And that should be guiding you for the different steps. But I included new tasks where you will be less guided because it's a senior researcher workshop. So you should have some challenges maybe today, a little bit. And you'll have 3 directories, one for each task. This morning we are just doing task 1, and this afternoon we will do task 2 and 3. And in these directories, you will have every time a Python script, but this time you'll have to modify it a little bit, and you'll have maybe to play with CDO a little bit to do some regrading. And but you can see normally, I mean, it's guided and I'll be here, so you won't be left on your own. And I can answer all your questions, but it's basically for the first task, you need to go in task 1 and you will find the files, the scripts, and everything you need. And I think that's all for this part. Oops. Do you have questions or?
There is nothing in the chat. And I strongly advise people, if they are not willing to talk, to write in a chat, or you can just unmute your microphone and speak. So if there are any questions, yes, please talk. If not, we can continue, Anne. So.
Okay, should we? I mean, I thought you wanted to keep the schedule for being sure that if people wanted to come at I guess 10 o'clock for the task, or do you want to start practical task 1 now, as you want?
We can if maybe we can ask if somebody has any troubles with the installation of the packages from in Anaconda. Maybe we can help. I managed to solve the problem. Actually, we managed to solve the problem here on my computer. So if anybody needs help, please just write in the chat, or we can try to solve the problem, and we can come back at 10 and then work on the practical part. Is it okay with you?
Yeah, perfect. Yeah, okay. I'll take care a little bit of my son and come back at 10. That's fine.
Okay, see you at 10 then. Okay. We have a nice camera here in the room, and it actually zooms us every time we press a video on a Zoom.
That's quite fancy.
It's actually quite interesting. As you move, the camera moves, so it's.
That's pretty good.
Yeah, it's interesting here in the room.
Did you get it with COVID? Like getting more and more. Because for us, we have a much better system at Cicero now that we had to do so many stuff online.
Yes, this is something new, actually. To be honest, I never saw this in my life. And as we move and speak, it actually focuses on the people sitting at the table. And when you stop a video, it just goes down. And when you press video, it goes up. It's really interesting for me.
Brilliant.
Technological miracle. Yes, so it's interesting, really interesting sitting here in the room.
Okay, should we start with a practical test?
Yes, please. Yes.
So I mean, I guess you have everything you need, but the first practical task is basically comparing outputs from a global climate model, a regional climate model, and from reanalysis. So reanalysis are a combination of observation and modeling. So it's basically starting to play with the data set that we usually use when we do climate comparison, or we do climate analysis on a region. So yeah, you'll normally be able to see what are the limitations or advantages of global versus regional climate models, and also do a little bit of Python if you're not used to it. So it's a combination, a little bit of learning about climate modeling and Python if you have not used it before. So yeah, if you when you start, normally everything is written, but if something is not clear, just ask me, I'm here.
Okay, so we should try to do it on our own. And if we are stuck, we will ask you. Actually, what I wanted to ask you about the CDO and regridding. We regrid the regional climate model to global climate model, or vice versa?
You have different ways of doing it. So when I prepared the exercise, one way I did it is actually I regridded all the different data sets on the same grid, but I choose a different one. Like I put, because you can do remap bill, and you can do, I put something in the, I'll put something for everyone in the chat. You can do remap bill and create, let's say, I'll put something, on a grid like R, regular grid 180, 380. I mean, it can be whatever you want, but you also have the choice to just regrid all the data set on a 1 degree grid, on a half degree grid, or whatever you want.
Okay.
Or you can regrid everything on the GCM grid. But in general, when you do regridding, it's better not to do too much towards the higher resolution, because it means that you're asking CDO to create information, and you should not expect that it's capable of doing that. So usually that's why, like for that 1 degree, a grid 1 degree, like in between the GCM and the RCM, can be a good idea.
So if you understood correctly, we will use an intermediate resolution between the GCM and the RCM.
Yeah.
Okay.
Yeah. I mean, different. We can do it in many different ways, and technically some stuff would work. But as a recommendation, I would recommend to be in between the GCM and the RCM usually.
Okay.
So, okay.
Yeah, and actually, yeah, it's more 180, 360. That's 1 degree. Yeah.
Muutui nas trzeba dać.
Co da?
Muutui nas. Okei. So, Anne, can I ask you please something?
Yeah, of course.
We are doing the regridding, and
Yeah.
may I share my screen for you to see what the problem is?
Yeah, of course. Go ahead.
Okay. We are stuck here in the CDO. So we made this my grid, that there is a file, my grid in my GCM folder. And when I do the remapping, I use my grid, the file I want to remap, and the file that I want to write it in. So when I do that, it first gives me a name list error and the character. And when I correct it, the character, it gives me this input file of process remap does not exist.
Okay, so can I check?
I'm not really, maybe to try to make the grid as you suggested, or I'm not really sure what this error actually means. Process does not exist.
Let me check.
Okay.
Yeah. You didn't put a space between remap bill and migrate, right? It's just
no. Is it really? Okay. Is it? Okay, let me just try.
No, because sometimes it's. I mean, sometimes it's something that we forgot. I'm just checking for obvious things first, and then
Too many input streams.
Oh, remap bill. That's. Oh no, yeah, you have a space between remap bill and migrate.
Okay.
That's the first thing, yeah, because that's why he sees input, output.
I have here one space, and
so that's good. Yeah.
Okay, and this is the input file and the output file. So
very good.
The same
so
error.
So this part process remap bill doesn't exist. That's something. Is CDO working? Can you just write CDO in your terminal?
It's working.
Yes.
Okay, good. Yeah, I'm just checking because in case.
You know what? Oh no, I did. I thought that maybe I forgot to put CDO, but it's not.
No, yeah, it could, but no. Okay, and can you do ls? So just that I see that the file is there.
This is the one that this is the same. Maybe I can try with another file, maybe.
That is weird, is that remap bill does not exist. And that's a part.
Let me see here, remap bill. Maybe I copied it wrong. Remap bill, okay.
Yeah, that looks good to me.
Remap bill, my grid. Maybe I don't know.
Can you just, without anything else, write in your terminal CDO remap bill?
Yeah.
It's just to see if it
recognizes any input streams.
But it's recognizing it. Okay. And can you try one thing instead of migrate? Can you try? You know what I wrote, like comma and R 180. Yeah, no space. Yeah, 180 X and 360.
Okay.
And then input file and output file, same as
okay. Input file.
Just to see if maybe there is something it's not recognizing.
Grid. And the output.
Yeah. .nc. Yeah.
Oh, it's working better. So okay. It's a problem with the grid file. So okay, I'll try with this is the GCM, and I will try with the RCM, and then I'll try to compute both.
Yeah, so that's what I've done when I did the test for me. Of course, I did it, and I used this R180 360. So I'm wondering if sometimes some versions of CDO don't have the same version of remap bill. So
probably, yeah.
I don't know, but at least this part should be working. I tested it for me.
Okay, now I'll try with the RCM and then I'll share the screen when I get the results, okay?
Yeah, sounds good.
Great. Okay.
Možda vidi x first, y first, to je bilo minus 179, minus 89.
Ovo radi kako ja rekla, daj, idemo sljedeći.
Aha.
Si nas mutira?
Da, nisu, vidi, sad ćemo probati.
Ne može ovako, mora sad da se vrati u drugi. Joj.
Oh, and one more thing, actually it's R360, 180. I always forgot that they put longitude first and latitude after.
Okay.
Yeah, but for me it should be lat in my head, but not in their head apparently.
Ok, znači mora da ide kako smo rekli. RCM, znači GCM, ok. I onda ga regridujemo kako smo imali malo pre. Samo ide 360, ide prvo latitude pa longitude. Pa jeste, znači mora ići na opačke.
Stavila je samo R.
Jo, fuck.
360x 180.
Tako? A?
R 360x.
Tako je.
I time je kreirala MyGrid.
Tako je. Pa viš da je prilično jednostavno kad si uhodan.
CDRM bil R 180x.
Tu nema zareza, nego sad moram da regridujem ovaj GCM.
Koji ide ta samo?
Ja sam prvi taj uzela.
Da, historik, a ja ću drugi.
Ajde. Kako mi se zvao? Output NC.
Dobro, kucam R 180 x 360, je tako?
Čekaj, 360, 180. R 360 puta 180. Sad meni to opet ne radi, isto mi izbacuje.
I sad stavim 300, tako samo, NC, to je input i out.
Meni opet izbacuje isto, Miku.
Out, NC. Šta, grešku, ja?
Da, istu grešku.
Unprocessed input, could not process all operator files. Unprocessed input, could not process all operator files.
Malo preradilo, šta je problem? GCM. Šta je sad problem, profu, malo preradilo? Kad je bilo 180.
Šerovala ona.
Da, i sad evo ponovo, ne radi. Input file.
Unprocessed input.
Vidite.
I tada si GSM uzela, ali tako?
Pa da, evo, radila sa ovim. Sada ja ne mogu ovo da vratim, ja ne mogu ovo da kopiram.
Ja sam uveđen da loše kucam ovaj A.
Može, daj da vidim.
A zarez, majku, zarez ide pre.
Da, 340. Do 180.
Da.
Radi.
A čekaj, šta je sad bilo?
Znate šta je bilo? Što sam ove drugačije označila, pazite, ovde je crtica ovako, ovde je crtica dole.
Ja, donja crta. A sad
Pogrešno sam kopirala.
Uradilo mi je.
Da, radi, super.
Zarez.
Sad treba da se prebacimo u ovaj RCM, gde mi sad da idem u taj task, evo ga RCM, CD-Cig drive, dobro, i onda uradim isti taj sa, jesmo RCM, jesam, LS, tu imam samo jedan taj. I sad idem ovako, i sad umjesto ovog, ovdje stavim output, RCM, da, ovdje brišem ovaj i samo prekopiram ovaj od gore, je li tako? Ovaj, tas eur. Evo ga.
Gde ga umetneš?
Materina. Greška. ovdje ga umjesto ovog, ovdje output ide RCM, a ovdje ovaj umjesto ovog uvodnog, ovog prvog fajla stavljamo drugi fajl. Tasmin, tralalala i sad kažemo enter. Evo ga radi.
Aha, ja RCM dižeš na taj migrate, aha.
Da, super. I sad treba da promenimo. Anne, I'm sorry, you were probably listening to us speaking Serbian.
No worries, I understand that you have an issue.
We actually managed to regrid both files from the GCM and RCM. And now we should rewrite actually to just correct the Python script to have the two outputs, two different pictures, two different, Okay.
But you need to do one more thing with CDO. You also need to select the same region of the world.
Because it should be too big. Yes.
Yeah, for CDO cell long lat box.
Yes, I will take the same box as you did in the.
You can use that. That's what I use also. Yeah.
Okay. Znači, moramo da mu uzmemo one, kako se to zovu, da ga ograničimo i sad se ja kontala da uzmemo ovo što je ona uzela odavde. Ovde 30, 75,5 i minus 20 do 50,5.
Šta minus 20?
Šta je to?
Meridijani.
Da, ali minus 20 je to je...
Čekaj, šta je ovde, ne čitam dobro, čekaj.
Jeste, znači odlazi zapadno.
Let's create map over Serbia. Aha, ne. 10,35. 10,35 to je 10 do 25 je longitude, 35 do 55 je latitude. Znači 10, kako sam rekla, 10, 25, 35 do 55. 35 do 55. Ok.
Ne vidim kako će ga odseći.
RCM, samo da vidim gde sam sad ovde. RCM. Znači moramo output da secnemo, a njega secnemo ovako.
Patnja sa ovim pitanjem.
Evo ga, paste. Cell on lat box, lon 1, idemo znači od manjeg longitude 10. 10, 25, 25, latitude 35.
55, rezi dobro stoje.
Da, i sad samo idemo in file, to nam je ovaj naš što smo ga sad stavili, output RCM.
I cell radiš u CDO, ili tako? CDO, cell, kako ide? Cell i onda 35.
Imaš mi ko onim notepadima što sam ti poslala. RCM, cell, lon, lat, box.
Aha. Ali ide zarez ili nešto?
Zarez, pa onda ideš longitude, manju pa veću, pa output file, to će da bude cropped.
Longitude ide 10, 35, je tako smo rekli, i latitude, ne, 35 do...
Uspeli smo, sad treba da se vratimo gore, samo sekund, da bude GCM. Evo ga, ovdje pisamo GCM. I sad isto ovo uradimo. Output, samo da vidim kako sam ga nazvala. RCM, task 1, GCM, output sam. Output, cropped, to je moj stomak.
Možda se najdeš.
Evo ga. Sada probam da ga u ovom Python skriptu ne CD, ne ovaj GCM, nego ide cropped. Cropped. Hoćete da bude admontovano, je li tako?
Da nas čuje.
Hoćemo da
Sì.
cenzurišemo, da isečemo.
Aj, sad da ima ako. Ne, nije dobro, sad ću mi isto ćemo nacrtati.
A cell on lat box, ok.
Kako je? Dobro je. Daj da vidim.
Čekajte da vidim.
35, 55,
To jeste, nego šta je on nacrtao sad?
10, 25.
Ne, on je nacrtao samo ovaj drugi.
Dobro je odsekao, ali nije sadržaj.
Latitude, longitude, latitude, longitude. Not relevant.
Kod mene nije dobro, nisam dobro uradio. Evo ga, ovdje nešto nismo netice, aha, a evo ovdje je greška. GCM, cropped GCM, net CD file, task stop, convert to Kelvin, ismet.
Alt, RCM i...
Aha, evo moramo ovdje ubacimo. RCM, to je i ovdje ide cropped.
Ok, uradio sam selekciju.
Ajme.
Kako se brzo plotuje plot u CD-u?
Nemaš tu plot.
A u cigvinu? A ne, neću.
Black and white. To si želela u tebe.
To mi je bilo.
Kako si ga?
Ne, pa nisam dobro uradila, znači nisam dobro nešto uradila. Šta ovdje kaže? Users korisnik size package. User converting a mask element to none. Dobili smo brdo kako se zove, ovih grešaka, ne znam.
Sad treba naći pravi. Ali...
Šta se dešava?
Evo.
Na šta?
Mi smo ga nacrtali, znači odradili smo, evo ga. Cropped, znači kropovala sam ga, sve je to u redu, sve sam ga izvukla na GCM i na RCM.
Mene jako sam nju biljo što je 1 KB my grid.
Ali crop, znači iseckano ti.
A crop je dobro.
Razumeš, iseckano ti na ovom.
Crop je ok, 103 KB, ali my grid je 1 KB. Ajde.
Ne znam.
Premalo.
Evo sad, ovo je nacrtalo.
Ovo je crop, aha. Kropovano.
Ali izbacilo brdo grešak.
Da vidimo što.
Vidiš, brdo, ja ne znam šta je.
Ček, stani, idemo redu. Warning, converting mask element to non-self Zmax.
Čekaj da se šerujem. Čekaj.
A opet će biti onaj range.
And I will share my screen because I have a bunch of errors and we don't know what those mean actually.
Are you in the Python script or are you in the...
I actually tried and changed the Python script and then I ran it in the prompt.
Yeah, you're supposed to get some errors. It's not supposed to work directly, so that's...
I will share the screen, so okay. This is what we actually got when we use the script. Let me just share the whole screen. It will be much easier. Okay, so share. This is the Python script, and here I changed the files.
Very good. Yeah.
Change the files and also here for the RCM. And when I run the script, I got these errors saying.
So I'll show you how to solve that. Can you come back to the script?
To the script. We are back in the script. Okay.
Yeah. So I need to remember the two things. So go down a little bit. Yeah, go down. Yeah, so here, oh, sorry, a little bit up.
Sorry.
Yeah, it's difficult when you're not on your.
Yes, I know.
Yeah, no, not. So you've changed. Okay, that should work. Let me check because I had written the.
Maybe because we use the same latitude and longitude to crop the file. So maybe we should change it this a little bit, longitude and the latitude.
Can you try? Do you see long lats equal np.matchgrid? Long minus 180. It's toward the end, just before plotting.
Here.
Yeah, and you need to remove the minus 180 because when you're doing the remap build, it's changing a little bit the format of the longitude and latitude.
Okay.
And I remember I had this issue, so that should help.
We actually get the maps. Those are the maps, but there is nothing on them. So
yeah, but try that. Try to remove minus 180 and save it and run it. And I guess that will be the issue for both files. You should try also remove
the second. Okay. I'll let him finish and then I'll change the second as well. Yeah,
because it won't. Yeah, it won't.
Okay, I'll go down and here before plotting, where is it? Where is it? Latitude, longitude. I don't see it here.
Okay, maybe for this one.
Just long lat.
Yeah.
It was just the first one.
Yeah, and then for the second one, you need to remove this hashtag here. Long lats equal np.matchgrid. Yeah. Long lats equal. Oh yeah, and you need to put xy equal map instead of long with a large character. It should be long and lat. Sorry, it should be small character LONS. Yeah, here and LATS.
Yeah, because here we defined it. Okay.
Yeah, so that's what I wanted to show you is that when you're doing this remap build, of course, you're changing a little bit the format of the grid, and it's not exactly the way the models give you the output. Then, yeah, CDO is doing something, and it's usually something you need to treat in Python or in CDO, depending on where you want to do it.
Okay, so
let's see if that solves some of your problem, because normally that's what I had. That was my issues. I remember when I did the test last week, I had this issue.
It's working. Yay!
Yay!
It's working. Great. Now we can compare them.
Yeah, now you can do the difference because normally they are both on the same grid.
Yeah.
So it should be easy to just add diff equal, your two, and plot it. And I put some recommendation on how you can change also the color map, and different things if you want.
Here are the two outputs, the RCM and the GCM.
Exactly. Yeah.
Yes.
Right.
So, okay.
Well done.
So we managed. Yes. Thanks.
Yes.
If anybody else needs any help from people who are working remotely, please write, and we will try, Minuta and I and Professor Pavic will try to explain as much as we can what we did step by step. So maybe easier.
And I can also do it. And I have, normally if you go in others, because I put little others, and in others, you have a script with all the different tasks, the steps, and it's normally working. So yeah, there is a backup option if you don't get it. Normally.
And here in this global climate model, we actually have some kind of overestimation here in the Balkan Peninsula and in the Central Europe, and we don't see the Alps like we see it in the RCM, even though they're on the same resolution now.
Yeah, and I think that's something to understand with this regional climate model, is that you're creating you have an added value. We call it an added value because you're really resolving better some processes. And as you say, it's that allowed us to represent the climate better, because it's not only about doing a linear interpolation from the GCM to the RCM. You need to have physically something that is represented differently. And in the RCM, the mountains are just, you know, not a huge square of 100 by 100 kilometers. It's much higher resolution.
Also here you can see the Carpathians.
Yeah. So and I guess when you know your region, you know you're able to spot what you expect. Yeah. So yes, that's exactly what I mean. And of course, the RCM must have some default, but it must have some mistakes too, because it's not perfect. But in this case, you're supposed to get an added value going from the GCM to the RCM. So
should I go through the steps, how we actually came to these photos, or you can also share your screen and show us step by step what we did, just for the people who are not here with us in the room. Maybe it would be much easier for them to understand what we actually did now.
Yeah, or is it better that I write it in the chat, maybe, so they have the comments?
Okay, and
yeah, I'm just wondering what is the best step, because then if people want to do it at their pace, they can just look at the chat and I can.
Okay.
Yeah.
Okay. So I'll stop sharing my screen now, or I can show that we actually regridded the. First, what we did, regridded the outputs of the global climate model and the regional climate model to this resolution. We got the output files, and then we changed the script, Python script, with this. Actually, we put in those files and changed what we changed here, latitudes and the longitudes, and erased minus 180 degrees. For the GCM, and for the RCM, we just used lons and lats that we actually defined here. So that's what we did, and we got the results here and here.
Yeah. And I'm putting the different steps in the chat, but if it doesn't work for you, please let me know and I'll help you solve the problem.
Okay.
Sada bio crno-belo, ali...
To moraš da promeniš. Sad čekaj, sad ću ti pokažem.
Slova, lac, lonc.
Pa to sam promenio.
Moraš da vidi.
Lac.
To moraš da ga odštikliraš. Tako je. To i sad ovdje lonc, lac. To ti je za...
Ali da li to recimo ili gde smo?
Nema veze, na dobrom si, ali na gornje vidi gore, kod RCM, moraš da izbrišeš desno. Aha, dole idi. Dole. Joj, nema mi tako ništa.
Sorry, evo ga recimo.
Ideš ovdje, ovdje treba da izbrišeš ovo 180.
Aha, minus. Samo jedno mesto.
To je to. I sad kad probaj. Mislim da bi sad trebalo da radi.
Aha.
Evo ga. Opet nije.
Crno-bela, šta smo još bili kod tebe?
Samo ono lonci lači.
Samo smo to.
Ne, samo na ta dva. Na donjem, vidi.
Find lac, lonc. Lonc, lac. A čekaj, mesh grid, je ovo?
Ne, to ostaje.
Malo, nije veliko.
To ti ostaje.
A mi smo u zagradi isto bili menjali. Čekaj. U mala slova je sa S.
Ti si Niko gde? Kod RCM, GCM.
Ja sam RCM računao. RCM.
Ali kad crtaš moraš ga saviti cijelog. Kod prvog brišeš minus 180 stepeni. Kod lonc lac jednako je NP mesh grid. Znači, tu brišeš minus 180.
Grid sam izbrisao, da.
Dobro. I onda ispod ti ostaje XY maps long slots. Dobro. I sad ideš kod RCM-a. Spustiš se skroz dole.
Znaš što je problem možda? Ja sam ubacio ovo putanju u RCM, input.net CDF file.
A ja, pa si stavio dobar.
Što sam isekao.
I moraš i za regional da staviš isto. Hvataš?
Shvatam, ali...
Kako si setno i regional?
Jesam. Zašto sam uradio? Oba sam zapravo regridovao.
Dobro. Jesi ih setno na onaj?
Ali jedan sam samo setno.
A setno na drugi?
Koji?
RCM.
RCM. Sam taj jesam.
Evo ga. Ona je sve ispisala.
So I put the different steps in the chat, at least for preparing the files, because that's the first thing you need to do. Yeah. And then you have to do some modification in the Python scripts, like the name of the files and a few things with the longitude and latitude, but just let me know if you have any trouble.
Input file. Change.
Da se ima na 12.
Treba i GCM, naravno.
Da, secneš, šta?
Secnem i da ga remapiram.
Ja sam to uspela da uradim, sad kako pojma nemam.
I sad idemo... Koji su ti od ova tri? GCM? Prvi, ja?
Da.
Pa neću dobro. Složeno. Da vidimo što je to.
Ne može.
Ne može.
Moraš da na desni klik.
Da. To se ustavljamo.
Jeste. Riši se. Ne može. Ne, kako ti hoćeš. Nisu desni klik.
Onda ću baciti neku gomilu.
Neće, evo ga.
Dobro.
Samo enter.
I out GCM će ti staviti. GCM. Dobro.
Enter. Evo, on je drugi. Sad odmah cell on lat, odmah u ovoj.
Da. Cell on box, out GCM.
Da, i odmah mu stavimo, znači, proxy.
Select GCM.
Da, i sad on enter. Evo ga, on je završio. I sad to uradiš isto sa ovim...
I to sam recimo sam već
i
sam treba u skriptu.
Tako je, ubaciš tu gore.
GCM, ovo, znači GCM out.
Kako ti je ovo? Select. I dole ti je select. Recimo, jesi tu sad?
Jesam to. Ja, čekaj.
A vidiš da bi ovdje ostao, onaj stari.
Sam da provjerim da li se select recimo. Čekaj, recimo select.
Što kaže TAS?
TAS, anti-variables, surface temperature.
A šta TAS?
A širo je pa vidi s njom. Daj da vidimo, vrati u ovom.
Skript, šta sam uzimao?
Može malo TAS.
malo preradimo. Ću da vidimo tačno šta je za grešku. Plannici variables time, trace back mostly files, 5 plus 29 in value. Key error plus.
Viđena se ova ovdje kamera.
17 sati.
Vi želite da ona bude non stop uključena bilja. Hoćete da bude uključena non stop ta kamera naša.
Pa i ne mora. Kamera bez
Cijela
veze.
minutira.
Mogu da
Yes, you just subtract one from another. Normally, because they are on the same grid and same region, you can just do diff, for example, equal, I don't know the name of your variable, but let's say task1 minus task2, for example. And then you can just copy, a part of the script down to do the plot, because it's just redoing the same thing. And I'm just thinking you can change the color map, because, for example, you might want to have a blue and red color map, and that's BWR, or you can change the space between the grid, the color map. I mean, you can do a few modifications, but basically it's just doing a difference.
We have to do the subtraction in CDO.
Do you? What's happening?
Or maybe some other tool. Can you suggest?
I think that we can hear in this.
Can we do with the net CDF files the subtraction outside?
Yeah, you can, but why? Do you have an issue with Python? Is it complicated?
No. We're just not sure which software to use, so we can.
You can do it in Python. I mean, just the line I wrote in the chat, you just add it to the code at the end.
At the end.
Yeah, at the end you do this, because it needs to have all the information from before. But
Sure.
if you want, I mean, in others, you have another script where I did all this modification. So if you want to double check what I've done, you can also look at the script in others. So it should be there.
Okay, so it's in the script or?
In the script.
Yeah, in the directory, in your directory, you must have GCM, RCM, reanalysis, and others, I guess. I can't remember. I can check where I put it. And in others, you should have another script.
Yeah, and, I can find it.
Okay, yeah.
And if you want to cheat, you can look at it. Yeah.
Now we can
And
see
that's
what you did.
Yeah, and that's also for everyone else online. You can look at the script and check.
Okay, now I understand. Now I understand. So, okay.
I didn't want to say it too early because you have all the, but yeah, you can look at because there are other steps coming, but you should see what I've done.
Okay.
A tu je subtrakcija, tako da?
Da. Evo ga diff.
Diff task.
Nice. And can we please discuss what we actually got on these pictures from these differences? I can share the screen and
yeah, maybe that will be good also for everyone else. So if you didn't get it, you can see yeah, what Biljana got.
Yes, this is actually what we, what we actually got. And here is the difference between the global climate model and the regional climate model, which means that the global climate model is actually here underestimating temperatures according to the regional. It shows lower temperatures by 10 degrees.
But of course, I mean, you should be careful because it's just one regional climate model and it's just one global climate model.
I understand, but I just want to know what actually those pictures represent. So maybe in the global climate model, we could get, if we are looking at one area of the globe, we could get the something like this, some underestimation of the temperatures and the changes in temperature.
Yeah, so usually what you see, I mean, is that, I mean, for example, regional climate models are better at simulating extreme events, extreme temperatures. Yeah. So you could imagine that the global climate model could underestimate the temperatures in a region. So that's totally plausible. So that's why, so yes, that's what you are seeing, that the global climate model is underestimating the temperature, and that's happening, unfortunately, maybe because it's missing some processes, doesn't see the mountains correctly, maybe precipitation, also other convection is not represented correctly. There are many things that can be not represented correctly and a little bit better in the regional climate model. So that's why the next step is also to compare with some sort of reference data set, some sort of observations. And that's why I included another step where you have the reanalysis data set ERA5, which has a reanalysis developed over Europe. I mean, globally, but in Europe. And you can compare your data set with reanalysis. And I guess you could, normally you should be able to trust more the reanalysis data set than the GCM or the RCM.
The global climate models are actually useful when you want to see the changes, for example, variations in different parts of the world. And the global and the regional climate model, if you want to go in depth analysis, for example, in some kind of extremes or I don't know, changes in temperature or something like that in one region. So for global climate model can identify the regions that have the most prominent change, for example, and then you can focus on that region using the regional climate model and going in detail.
Yeah, so that's one, I mean, that's a good way of seeing it, and that's one application, but it also depends on what you're looking at. Because, for example, if you're in a very flat region where the climate processes are maybe a bit easier, maybe you won't need the regional climate models because it's the global climate model will have good abilities in this region. So it also depends on where you're looking at, which process. And also, but the scale, because sometimes you just want to look at stuff globally. And of course, your global climate model is very valuable in this case. But it's a good way to see it, because what you're doing is that basically you're zooming over a region, but except of you're not doing it just doing an interpolation, you're really using physical processes to do this kind of zooming or interpolation. So you're having this added value, but it doesn't always work. Sometimes the regional climate model can also bring these errors, but it's a good way of seeing it. Yes.
Okay, thank you. I can stop sharing my screen now. Okay.
Yeah, and I guess the next step should be to compare with ERA5. If I can check my notes. Yeah, the next step is to compare with ERA5, and you will see that again, it's a different grid. So you need to do regrading, and but I mean, you've done it, so normally it should be quite straightforward. It's just the same technique. maybe we can stop task 1 in 5 minutes and yeah, have time to discuss it a little bit. Because I think, I mean, you've done the most important part anyway. The most important part was this yeah, comparison of the different data sets. Then it was more optional.
Yes, jesi me mutirao? Odmutirao si?
Nisam.
I actually managed to also plot the maximum temperature for a global climate model.
Cool.
Here. But I didn't find the maximum temperature in the regional climate model.
No, I think I had only put it for
Yeah.
one type of model because I didn't think we would have necessarily, I mean, I didn't know if we would have time to do it, but then it was really just optional to change variable.
Yeah, it produced a nice picture. Okay. Evo gasi sad.
Opet test.
Trebam ću.
Opet u testu sam ono zaglavio i pokušao da promijenim task max, ali verovatno sam negdje pogrešio. Tas jednako je task max.
A gledaj koji?
DCM,
A koji je to onaj?
Pa taj što sam radio, da.
Tu task max onda pišeš.
Task max, ajmo next.
Ima još negde.
Da, opet čekaj, task, to je dobro.
To je dobro zašto ga uzima gore.
Dobro, task.
To dole treba ti gore, čekaj. Ne, to te postaje zato što si to nam... Ne. Sve bi trebalo ti radi dobro.
Da. Tas je u redu, tas je u redu. Vidiš i tu sam stavio tas.
A koja je to?
To je...
Regional nema maksimalnu temperaturu, znači samo ostaje tas.
Eto, sad.
Eto.
Ajde.
Regionalni nema, znaš.
Maksimalno.
Nema.
Čekaj, onda s čime računam?
Samo sa globalnim, onaj drugi ti je globalni.
22 tasenci, variables, tas, key error tas.
29 ili tu ti negdje početak. Znači, tas...
Line 70.
Čekaj, da dobar skript. Aha, čekaj, skript task 1, pa je nije mi je test. Pogrešno sam skript.
Regional.
Test, taj.
Ju kamera, znači on zdražen.
Tu smo sad.
Kako programiramo, sve zvoni.
Kamera se raspada, čoveče. Ne može da propratiš.
Meni si do WC. Ne mogu, koliko smo u kraju, ha?
Koliko još imamo? Imamo još
15 minuta.
15 minuta.
Znači onda recimo nema task max, ok. Save. Test. Evo ga.
Miko, šta je ovo?
Šta si dobila?
Klimaton Beograd pridruži se najvećoj kolektivnoj klimatskoj akciji na svijetu. Šta je to? Timski hakaton.
Ne znam za to. Kad je to?
Transformacija javnih prostora iz sivog u zelena, podrška zajednice. Klimaton Beograd je na... Šta je bre to?
A koji sad mjesto dobila?
Na Facebooku.
Aha.
A jeste me iskačio.
Ja ne znam šta je ovo.
Ko to organizuje, da.
Znaš, prosto mi je nevjerovatno, ono, mi se Bog te bavimo time, nas niko. Aha. Hvala. Mutiraj. And we went through all the tasks until, actually subtasks until the practical task number 2.
Okay.
Managed to regrid and replot the maximum temperatures of the global climate model and the ERA pit. So should we discuss or?
Yes, yeah, I think there are 2 things I was thinking. In the remaining time, we can just discuss what you see with the ERA 5 data, the difference between, I mean, GCM or RCM and ERA 5. And I was also thinking that maybe for the people I didn't talk to, maybe you could put me in the chat, what is your research on? What do you work on? Just because we can have other discussion this afternoon, and I can also try to think about what I that know and that I could be useful for your research. So,
please.
yeah, I can also write it.
Okay.
Or maybe we can do it, or use.
I'll take a second. Maybe while you share your screen with the plots you have for the reanalysis.
Yeah, I can share it. Here are the plots for the regional climate model and the reanalysis. On the same resolution, I regridded it and plotted. And I can put up also the global climate model, but I think these 2 are enough.
Yes, just so yeah. I mean, basically, what I wanted to show you. I mean, first is that you can use reanalysis to assess how your climate data are, but the reanalysis are not perfect. They are a combination of observation and a model. So, I mean, yeah, you can also use other type of data. You can use satellite data, you can use ground observation, because maybe when you look at the regional climate model, you can see that, I mean, regional climate models can go sometimes at higher resolution than reanalysis. So yeah, sometimes maybe your regional climate model in some regions can be better than the reanalysis, because also in some regions you don't have a lot of observations. So yeah, sometimes reanalysis are just another model. So it's just, reanalysis are good, they are based on observations, but they are not perfect. So yes, just something to remember. You can also use several reanalysis, and they are available to everyone. So yeah, you just need to create an account, and you can get the access to reanalysis everywhere over the globe. So just something to remember when you look at regional climate models. And I guess for the next thing that I was thinking, like maybe, I mean, we'll be done. I mean, I guess we'll take a break at 12, but maybe you can just tell me in the chat or orally, what is your research on? Do you use climate data? Do you plan on using climate data? And if yes, I can maybe try to think about data set that could be useful for your research. So yes, I'll put that also in the chat. And yeah. Oops, the chat has moved. Okay.
Oh, dear.
Because I mean, this afternoon we have 2 other practical tasks, which it's also for learning a little bit more about dynamical downscaling or regional climate models. What are their strengths and weaknesses? But there is plenty of time to discuss other things related to climate data or dynamical downscaling. So if you need, if you want to discuss some parts of your research that could be related to dynamical downscaling, really do not hesitate to bring it on. Yeah. Do you have other questions before we start? We stop at 12. We still have 10 minutes. I mean, we can stop now, but if you have other questions. And I guess we'll let that open. I was thinking during lunch, if people can, just write what they have their research on, it will still be okay. Yeah.
Nobody has any questions or comments, maybe we can have a break And then when we come back, we can continue with the practical tasks. And if somebody wants to share their research plan or something, they will step forward. And also we have some questions, Minuter and I, about regional climate models, and because they take up a lot of space. When you download all the data, what is the best solution for example, downloading 5 different or 10 different RCMs and doing some analysis? What is the option for that? So that will be the question after. Yeah, so thank you.
Or maybe avoiding downloading, but doing some process or sub setting on the cloud or some server.
Yeah, I mean, Marit would be better for that, but I can at least tell you what I have done in the past to save me some space, because it's clearly an issue and becoming more and more of an issue. But I guess it also depends on what you can do, but we can certainly talk about it this afternoon, because I have different suggestions depending on what you
okay, that would be great. Yeah, thank you. So